our second lesson on sequences, and it's from lesson 4.2 in your HMH textbook. Okay. The essential question: what is an arithmetic sequence? Learning goal: I can identify a rule for an arithmetic sequence that models the situation. And so, sorry, cat and dogs are going to start fighting, so I have to hold the cat. We started this on Tuesday. Okay, so we're looking at what an arithmetic sequence is, and now we're going to look at how we can construct one. And so this first slide for you is an interactive one. All right, and so if we take a look at this, this is a real life example of when an arithmetic sequence can be utilized and used. So it says you can order tickets for the local theater online. There is a fee of $2 per order. Matinee tickets cost $10 each. The total cost in dollars of ordering N matinee tickets online can be found using C of N is equal to 10N plus 2. C of N, that is a function. Okay, a lot of times we see some functions with an F of N, but you can have different letters. That's okay. So our function is C of N is equal to 10N plus 2. That 10 is coming from the fact that each ticket costs $10. And the N is the number of tickets, right? So one ticket, if it's 10 times 1, you're paying $10 for the ticket. If it's 2 tickets, 2 times 10, you're paying $20 for the tickets. But also we have to add 2 here because there's this fee that they're charging for an order. So it's a $2 fee. And then our table below is showing the cost of 1, 2, 3, and 4 tickets. And so what you're going to do is draw on this slide, and you're going to complete the table of values for C of N is equal to 10N plus 2. So you're going to go through, and if 1 ticket is what is purchased, what's the total cost? Okay, if I put, and this is like our warm-up today, the poll. The poll was like a warm-up. So if I put a 1 where the N is here, 10 times 1 is 10 plus 2 is 12. So I put a 12 right here. Okay, and if I show some responses so far, here's somebody who's already started it. I'm going to give you guys a couple minutes to do this. All right, so work on this for a couple of minutes. So I have 3 responses so far. Everyone needs to participate. And I just told you what the first answer in here is. So if the only thing you can do, because that's all you understand right now, is to put a 12 right here where my cursor is, then do that so that way you're not losing your participation credit for today. Okay, you have to participate. Don't be afraid to make a mistake. Try to fill out these other ones. If you plug a 2 in where the N is, 10 times 2 plus 2. What goes here? What goes here? What goes here? And then also, what is the domain of the sequence? We talked about domain and range of functions and sequences on Tuesday. Do you remember which numbers those are? We have 10 out of 16 responses. We're up to 11 out of 17 responses. Okay, so I'm going to go ahead and show our responses. So right here, this person has the correct values for the cost: 12, 22, 32, 42. This is correct. All right, and the domain of the sequence is 1, 2, 3, 4. That's absolutely correct. All right, so this is good. My guess is maybe this is Mauricio because there's an M there. I don't know for sure. I'm sure Mauricio will tell me if it is him. Again, this person got it correct. Nice job. Slightly off on our numbers here. 12, 22, 32, 42. That's correct. Domain is 1, 2, 3, 4. Okay. And so you will be able to go back and fix your responses, but I am going to move everyone forward at the same time. And so now that we know for this cost of tickets at the movies, that the total cost is represented like this, and this is the domain. Next part, B, what is the range of the sequence? What is the range? How do you figure out what the range is? And C, what is the first term of the sequence? So if you guys remember when we were doing our notes last Tuesday, we talked about what it means to be a term. What is the first term? And then D, okay, find the difference between each two consecutive terms in the sequence. So I'm just asking you here for part D, which is probably the easiest, to just subtract. What's 22 minus 12? Because if I subtract these two numbers, I want to know what's the difference. What's 32 minus 22? If I subtract these, what's the difference? I'm trying to figure out what am I adding each time. If this is an arithmetic sequence, then I would be adding the same number each time. And so these differences here should be the same number. The amount that you add each time, we call it the difference. Right, so I have 5 of you that have responded so far. Take a minute and go to your Pear Deck tab and try to fill in as much as you can. Okay, so I have 8 of you that have responded out of the 18 that are in here. Again, we have 21 students in the meet. I'm still missing 3 people from being in the Pear Deck. And I can see who you are, and you're not getting the credit. You got to do it. You got to stop watching Hulu, and you have to do what you're supposed to. All right. Oops, I hit the wrong button. Okay, so I'm going to show some responses here. The range. Absolutely, take the total cost values. That's the range. First term in the sequence. The first term in the domain is 1, but the first term in the sequence is not 1. These differences are all 10. That's correct. And so here's the correct range. The correct first term in the sequence is 12. That is correct. It's 12. Okay. The sequence comes from the function. So the sequence is the outputs. 12, 22, 32, 42. That's the range. Range, output, those are the same thing. Find the difference. These are all 10. That's correct. Good job. Just another person got it correct. This person got the differences correct. Okay, so you will be able to go back and change your responses here, but I am going to move everyone forward. Okay, and so we're looking at vocabulary now. we defined arithmetic sequence on Tuesday, but I'm defining it again just a little bit differently now. So it's the difference between consecutive terms is always equal. So when you have an arithmetic sequence, the difference between consecutive, like in a row, the terms, is always the same amount. On this example, our difference was 10 each time, okay? Because we're adding 10 each time. So that's an arithmetic sequence. Common difference, the difference between consecutive terms, and it's written as D. So in this last example, our common difference was 10, and you can represent it with a lowercase d. Now, when we do arithmetic sequences, there's two types of rules that would make up that sequence. The first one is called an explicit rule. And I put a blue box around this because during this lesson, we're going to be looking at these two different types of rules. And every time we look at an explicit rule, I'm going to put a blue box around it. And it's the nth term of an arithmetic sequence is defined as a function of n. A recursive rule with the green box. So when we look at recursive rules today, I'm going to have a green box around it. The first term of the sequence is given, and the nth term is defined by relating it to the previous term. All right, so there's a difference here, and we're going to see what that looks like. Here's an example where we have a table of values, time and months. So for n, we have 1, 2, 3, 4, 5, and the balance, f of n, 2,000, 2,500, 3,000, 3,500, 4,000. This is a table that shows the monthly balance in a savings account with the same regular monthly deposit. Okay, so if you look at this, you can figure out how much they're depositing every month. And the savings account begins with, they're telling us we're starting with $2,000. That's why at month 1, we have $2,000. And the same amount, $500, is being deposited each month. So we're increasing by $500 each month. So from this, we are going to write the function as a recursive rule and as an explicit rule. So we're going to write the sequence, the arithmetic sequence, as a function recursively and explicitly. So we're going to use both of these. All right, so the first one here is a recursive rule. The recursive rule in the definition back here says the first term of the sequence is given, and the nth term is defined by relating it to the previous term. And so that's what we have here. The first term is given. F of 1 equals 2,000. So the recursive rule is f of 1 is 2,000. And then using the common difference of 500, we can write the rule here, the recursive rule, the function of n, f of n is equal to f of n minus 1, which just means the previous value in the sequence. Okay, if n is 5, then f of n minus 1 is 4. So that would be like f of 4. And then you add $500. So this is a way of showing how you get any value in this table. So like maybe we want to know 10 years from now, how much money is in our account. You know, this way of just filling in the table may not be the most efficient way to figure out how much money is going to be there, but using a recursive rule or an explicit rule would be much more efficient, because then I could just do the calculations for 10 years, there's 12 months in a year, so 120 months later. Okay, I wouldn't want to fill in a table that goes all the way up to 120, but I could, for n equals 120, okay, figure it out this way. And then our next rule is an explicit rule. And so if we look at the table, this is just taking this table and kind of rewriting it a little bit differently. All right, so if n is 1, f of n is 2,000. If n is 2, f of n is 2,500. If n is 3, then f of n is 3,000. And so how are we getting these numbers? Just by figuring it out without having to use a previous function. And says since d is always multiplied by a number equal to n minus 1, you can generalize the result from the table. So the explicit rule here is f of n is equal to $2,000 plus $500 times the amount of n minus 1. So if I wanted to know 10 years from now, when n is 120, how much money is in this account, I would just plug 120 into the function. 2,000 plus 500 times n minus 1, 120 minus 1, so times 118. Okay, 500 times 119, big number, add 2,000 to that. That is the amount in the account. Okay, so these rules help us figure out values like way down the line. Interactive slide here for you, okay? So there's two examples. Here's one example. I have f of 1 equals 58, f of n equals f of n minus 1 plus 7. This is a rule for a sequence, but is it a recursive rule or is it an explicit rule? So you're going to decide which kind you think it is, and you're going to drag the appropriately colored dot over it. And then over here, we have this sequence, this function, f of n is equal to 58 plus 7 times n minus 1. Is this an explicit rule or a recursive rule? I'm going to put you on student pace so you can answer this one if you want to go back and look at the definitions. I'll give you a minute to do this. Drag your dots. Gotta drag the blue and drag the green. And you can go through the slides right now. I put you on student pace. You can go back and look at the definitions. I have 10 out of 20 responses, 11 out of 20, about 30 more seconds. Which one is recursive? Which one is explicit? $14 out of 20 responses. You almost have everyone participating. Almost. Okay, I'm going to go ahead and stop the student pace mode for a minute, and I'm going to show you responses. We're totally undecided as a class which one goes where. Okay, so it's okay. We're learning this right now. So let me ask you this. Look at these two different sequences. This is one example, and this is another example. I want you to look at them and notice what's different. What do you notice that is different from one to the other? You can type it. You can say it. What's different? One is longer. Okay. How is one longer? What does it have that makes it longer? We have to figure out what's different about them so that we can figure out which one means it's recursive and which one is explicit. F of 1 equals 58. Perfect. You guys see that? How right here, f of 1 is equal to 58. This has the function at 1. This one does not give you the function at 1. Only one type of rule has to give you when f of 1 what it is. All right? And right here, the definitions, explicit to recursive. Recursive rule, the first term of the sequence is given. That's what f of 1 is. The function at 1 is the first term of the sequence. So the recursive rule is always the one that has f of 1 equals. Right? So do you want to change your dots? The recursive rule is always the one that gives you f of 1. So this is the recursive rule. This is the explicit rule. Green on the left, blue on the right. All right. There is another difference between these two. And that's that the function of n minus 1 is within what the function is here. Okay, so in the f of n, it's defined with the function of n minus 1. Where over here, f of n is defined not with another function inside, but you can use n minus 1 inside, as long as there's not another f. When there's another f inside, this is recursive. Okay, we're getting close on time, so let's move on. Number 9. These are the general ways of writing a recursive rule and explicit rule. And so if I want to write a general recursive and explicit rule for an arithmetic sequence, so right here, this sequence that I'm given, this example is 100, 88, 76, 64, and so on and so forth. So anytime you want to write a rule, you can write both a recursive rule and an explicit rule. There's always two things you have to figure out. We have to figure out what f of 1 is. What is the first term in the sequence? That's what f of 1 is, the first term in the sequence. So the first term in the sequence is 100, yes. And the other thing we have to figure out is little d, the difference, the common difference. All you have to do is see, what do I add each time? Subtract the two terms to see what we add each time. Now with this sequence, these numbers are getting smaller. Okay, we've looked at other ones where the numbers were getting bigger. And so the common difference here, instead of adding 12 each time, we're subtracting 12 each time. And that's okay. So we just write the common difference as negative 12. Once you know those two things, you know what f of 1 is, you know what little d is, you just plug them into these general rules. These are like the cheat sheets of how to write the rules. So the recursive rule, okay, you have to give f of 1 equals 100. We figured that out already. And then you write f of n equals, okay, equals f of n minus 1. We put that there. And we put plus d. So plus negative 12, it's the same as minus 12. Then you write 4n is greater than or equal to 2. Done. That's it. The explicit rule, okay, here's our general rule here. You write f of n equals f of 1, but we know what f of 1 is. So we write f of n equals 100, and then we put plus d times n minus 1, okay? D is negative 12, so plus negative 12 is minus 12 times n minus 1. And that's it. Okay. Multiple choice here. We're close on time. I'm going to give you 1 minute. It is a multiple choice answer. Choose the correct explicit rule for that table of values. Remember, guys, all you need to know to write an explicit rule or a recursive rule is you need to know what is the function at 1, what is the first term in the sequence, and you need to know the common difference. Those two things. F at 1, little d. First term in the sequence, common difference. First term in the sequence is 8. Okay, because at f of 1, it's 8. Common difference, what do I add each time? 4. We're adding 4 each time. Once I know those two things, I can then pick the correct answer. Okay, A is the correct answer. F of n equals 8 plus 4 times n minus 1. A is the correct answer. Moving quick because it's 58. Choose the correct recursive rule. Same table of values. We already know f of 1 is 8. We already know the common difference, little d, is 4. Now we're doing the recursive rule. This is the recursive rule. Which one of those shows this? With f of 1 equals 8, and it shows adding the correct common difference of 4. Okay, we're so close on time. F of 1 equals 8. F of n equals f of n minus 1 plus 4. It's A. A is the correct answer. You are on student paste. This is the last slide. This completes the set of, this completes our notes.